let's talk about how some people thought about what the revolution was then. It wasn't that somehow this was a totally different weapon. It's that it was just incredibly efficient in doing what we were doing before. Instead of 6 months, you had a nanosecond. Instead of 75,000 troops, 9,000 casualties, one bomber, no bomber losses. The Cold War actually embraced initially this objective of going after civilians. There initially were exercises, Half Moon, Fleetwood, Double Star, Trojan, Off Tackle. They involved hundreds of bombs being dropped on as many as 70 Soviet cities, destroying, you know, enough to quote unquote kill the nation. I mean, we're talking about, you know, 2 to 4 million casualties or deaths. And there were debates. The Navy, which was closed out from doing this mission, wanted aircraft carriers, imagine that, wanted some money. And one of the arguments they made was, you know, doing that is immoral. Kind of interesting. By the way, I think they actually were earnest about this. I don't think they were just arguing it. I think they actually believed that. Because you know what? Maybe that is true. Point is, the rejoinder was, well, war is immoral, it was argued. And, you know, we have to do this. Part of it had to do with not having enough money to go conventionally, not having very good technology to hit targets. Still basically the same technology. Now, admittedly, at the end of the Second World War, we got within like 1/8 of a mile of where we wanted to be, instead of 75 square miles away. But that's because there was no air opposition. It's still, at the end of the Second World War and the beginning of the Cold War, we still had a lot of Second World War technology. It was not that great. In the Korean War, what did we do? This is a stunner. 1 to 2 million people were killed. Everything on the surface of North Korea was flattened. There were more bombs dropped than in the entire Pacific campaign during that war. And here is how Curtis LeMay, who was a very bright guy, very smart guy, argued about this. There are no innocent civilians. It doesn't bother me so much to be killing the so-called innocent bystanders because, well, everyone's involved in this. We killed off, what, 20% of the population in Korea, and he bragged about this. You can see why there was a debate on whether or not we should use nuclear weapons. It was in that context, because we did debate that to end this war. We weren't that far off from doing it conventionally anyway. Actually, this is a much bigger thing than dropping a bomb. We forget, but throughout the 50s and in the early 60s, we talked about Bravo and Delta targets. Some were cities, industrial complex, some were military targets. But the implications during this period was that you're going to miss by so much. You need to lay down so many weapons to hit the military target that the collateral damage of hitting civilians would still be measured in millions anyway. And so people, as much as they wanted to hit the military targets and talk about emphasizing that, also said, well, you need to use these things like you'd use a bullet. Now, that may make sense if you're trying to not spend money, but you know, these things were a lot bigger than a bullet, and they had kind of consequences that were bigger than a bullet in war. To try to justify containing budgets, people said, well, all we need is 25% of the Soviet Union's population to be held at threat. I mean, that's how they started to talk about this in the 60s. It took a while to move away from that. All right, let's race through this. Does anybody know what a kilogram is in pounds? 2.2 pounds. Does anybody know what a metric ton is? How many kilograms is a metric ton? 1,000. Kilo, 1,000. And 1,000 times 1,000 kilotons is a megaton. All right, the largest munition in the Second World War was something called the Grand Slam, and it was, you'll read in the notes, and we have to correct this, I made a mistake. It should be that although it weighed 1,000 kilograms or 10 tons, I mean, excuse me, not 1,000 kilograms, at 10 tons, only about half of that was high explosive. The rest of it was just an iron case, and that's the weight was 10 tons. But that was the biggest thing. We used that against the subpens in France. I mean, believe me, it made quite a dent. I mean, it was quite. Also, keep in mind, a half of a ton. I mean, half a kiloton. Let's say half. It's oh, now wait a minute. That's a little off. Okay, we'll get to it later. What is the largest munition, conventional munition, we currently have? It's the mother of all explosive. Yes, what is that? What is the MOAB? What is its yield? Tenth of a kiloton. All right, and the Soviet effort led to a Russian effort where it's 4/10 of a kiloton. The reason I bring that up is the next step is a kiloton, or 10 kilotons in the case of Hiroshima, roughly 10, 12, 15, thereabouts. And you can see how this climbs. It gets bigger and bigger. Another, ooh, wow, okay, so now we're up to almost 50 megatons. Logarithmic paper can sort of do justice with this. If we didn't use logarithmic paper, the point at the bottom to the point to the top would have to probably go up to the, Washington Memorial, the top of the Memorial Building or something. So I use logarithmic paper so you can see it, because we can't go outside and go up that thing. It would take too long. But this gives you an idea, historically, what the growth in the yields were. And this was what the Great Revolution was about. Look at what we can do with yield. And you wanted to get bigger and bigger yield so you could kill that nation, use less bombs, knock that city out, hit that industrial military complex, and get the moral bonus effect of killing people, roughly. Now, we got that wrong with regard to thermonuclear technology, and we'll talk about this later. It turned out thermonuclear technology, which was promoted to kill bigger cities, if you will, turned out to be valuable in making them very, very small and tactical. And we just didn't understand that. It took some time to figure that out. And actually, making the nuclear stockpile more discriminate was brought to us by the thermonuclear revolution, but we didn't know that in the beginning. In any case, how does this relate to lethality? Essentially, I guess we cut it off at 5 psi, the complete destruction of ordinary houses, moderate to severe damage to reinforced concrete. If you take a look at that, the Hiroshima bomb dropped on us right now, where we are, would be out to the Ronald Reagan building, basically, or a little bit beyond. That's 15 kilotons. Here's 45. That gets you, take care of Roslyn, it looks like, maybe. This is the first thermonuclear test, 10 megatons. You get out to Gaithersburg in Germantown. Do you know why the Atomic Energy Commission is in Germantown? It's because of this map. So it would survive. We don't care about the rest of the government, but the Atomic Energy Commission should be functioning after they drop the big one on the Capitol. Okay. Zara bomb, 50 megatons, well, you get into Baltimore. Okay. So they give you some idea, scaling. Let's qualify it, though. Most people think that if you increase yield, it increases lethal area in a linear fashion. But that isn't the way physics and engineering work. When you set off a really big explosive, most of the energy is blown away from the plane of the target. It goes literally up and away. You can see that in the case of a ground burst absolutely clearly. So what you're describing is the release of energy as a sphere, not, oh, all of the energy goes to the target, focused like some kind of laser beam. there's a lot of waste. We waste a lot of yield on point targets. This is described basically by this formula, y yield to the 1/3 power. Does anybody here know what a 1/3 power means? Cube root. You're dangerous. They let you work up here? Next thing you know, they're going to be asking you how to do things.
Math degree.
Math degree. Actually, this is almost arithmetic, right? Okay, cube root. Well, what's a cube root? 1,000. What is the cube root of 1,000? It's the number times itself, times itself, times itself, 3 times. So it's 10. 10 times 10 is 100 times 10 is 1,000. Cube root. All right, so you take the cube root of the yield, and that gives you the relation when you multiply it times a constant. I won't bother you with what that is, to get what you're really going to get in the way of lethal area. Let me show you how that works. So if you increase the yield 1,000-fold, you don't increase the lethal area 1,000-fold. You only increase it 10-fold. So instead of having a lethal area that takes you to Chicago, that would be 1,000-fold. You're lucky if you get to, I don't know, my house,